If you've ever written even a single line of Python, you definitely know the feeling. You've been working on your code, you finally run it, and then boom, it breaks. Well, today we're going to flip that frustration on its head. We're going to see how Python's error messages aren't your enemy at all. In fact, they're your single best guide to writing better code.
Ah yes, this old friend. That flash of red text that just fills the screen, the traceback. It feels like a digital brick wall, right? It stops your program dead in its tracks. And if you're just starting out, it can really feel like a sign that you've just failed.
But hang on, let's just reframe this for a second. What if we've been looking at this completely wrong? What if that traceback isn't a dead end? What if it's actually a super detailed map pointing you directly to the problem?
To start using that map, we first have to learn the language of errors. And it turns out there are really three main types of messages Python is trying to send us. Learning to spot them is the absolute key to figuring out what went wrong and how to fix it fast.
So first up, you've got your syntax errors. Think of these as the grammar police of Python. They stop your code before it even gets a chance to run. Then you have exceptions. These pop up while your code is running, usually when it's asked to do something impossible. And finally, you have the sneakiest ones of all, logical errors. This is when the code runs perfectly fine, but it silently gives you the wrong answer.
Let's kick things off with the error that pretty much every single beginner sees first, the syntax error. This is Python's way of politely saying, I'm sorry, I literally don't understand what you just wrote.
A syntax error, which is also called a parsing error, just means your code has broken one of Python's fundamental rules. It's kind of like writing a sentence in English with no punctuation or with jumbled words. The computer, just like a person trying to read that sentence, gets confused and just can't process the instruction.
Forgetting the colon after an if statement is a classic example. But look at what Python does. Instead of some vague crash, it stops and tells you exactly what's wrong. Syntax error, expected colon. It even points a little arrow to where the mistake is. So this isn't a failure, it's a direct, helpful instruction on how to fix your code.
Okay, so you fixed your syntax. Your code is grammatically perfect, and Python starts running it. You're feeling good. But that doesn't mean you're out of the woods just yet. This is where we run into our second major category, exceptions.
And this is a really crucial difference to understand. With a syntax error, your code is so unreadable to Python that it never even starts. But with an exception, your code is perfectly valid. Python understands it. It just hits an unexpected snag while it's in the middle of running, like being asked to do something that's just not possible.
Let's meet a few of the usual suspects. You'll see a name error all the time. That just means you try to use a variable like hi_score before you actually created it. A type error happens when you mix and match data types that don't belong together, like trying to add the text 2 to the number 2. And an index error means you're asking for something from a list that just isn't there.
Let's really break down that index error, because it all comes down to one simple rule. Python starts counting from 0, always. So in this list with 3 items, apple is at index 0, banana is at 1, and cherry is at 2. So what happens if we ask for index 3? Well, there's nothing there, and Python correctly raises an index error, telling us we've gone outside the list range.
All right, now for the sneakiest, most frustrating errors of all. Your code has perfect syntax. It runs without a single exception, but the result it gives you is just, well, it's wrong. Welcome to the world of logical errors.
A logical error is a flaw in your thinking, basically. You've told the computer to do something and it's done exactly what you said. The problem is, what you told it to do wasn't actually what you meant for it to do. These can be the absolute toughest bugs to find because there are no error messages to guide you. The program thinks everything is fine.
Check out this factorial function. The goal is to calculate 5 times 4 times 3 times 2 times 1, which should be 120. But the code uses range 1, n. Now here's the catch. Python's range function always stops before it gets to that second number. So it only multiplies 1, 2, 3, and 4, which gives you 24. It's a tiny off by 1 mistake in the logic, but it leads to a completely wrong answer, and you get no crash to warn you about it. So we've seen errors that stop our code cold and errors that silently mislead it. But what if we could actually anticipate these problems? What if we could tell Python exactly what to do when they happen, instead of just letting it crash? Well, that's where error handling comes in.
And your number one tool for doing this, your superpower really, is something called the try except block. This is an incredibly powerful feature that lets you write code that can handle exceptions gracefully instead of just, well, giving up and crashing.
It's actually pretty simple. You put the code that you think might fail inside the try block. Then you tell Python what to do in the except block if that specific error happens. If everything goes smoothly and there's no error, the except block just gets ignored completely.
And just look at the difference this makes. On the left, without error handling, trying to turn the word 10 into a number crashes the entire program. With a value error, game over. But on the right, by wrapping that same risky code in a try except block, the error is caught, we print a helpful message, and the program just keeps on running. No crash, no drama. It's a total game changer.
And that really brings us full circle, back to our main idea, which this quote captures perfectly. When your Python code breaks, that error message isn't there to stop you, it's there to help you. It's your guide.
So the next time you see that wall of red text, don't panic. Take a breath, and here's a pro tip. Read the very last line of the error message first. That's the secret. It tells you exactly what went wrong. Let it guide you to the solution. It's a skill that turns that feeling of frustration into a feeling of progress. So, I'll leave you with this question to think about. What's the one Python error that always seems to trip you up? Because figuring that out is your first step to mastering it.